Shani gang, I'm Mohammed Zan. Welcomes you to Gyan Station. In previous lecture, we have studied about the contact force in last topic, and because of some reason, I was not able to show you the examples of contact force. But now I will show you the examples of contact force. Here, the examples of contact force are given. Wait a minute. Here, the examples are given of contact force, so you can note down this thing. I know you are habitual with these two forces, but with this force you are not habitual. I will explain it now only. So let's go. I will explain it on the whiteboard. Wait a minute. Yes. Okay. The first force that is new for you is the normal force. Normal force is nothing but the pressure or a force applied by an object to hold the item on its position. Like if there is a table, wait, like if there is a table here, on this table a rock is there, then this table is applying a force towards the rock, and rock is pulled down by the gravitational force. But the force applied by the this table, which is this arrow, is known as normal force, because table is applying the force on rock towards upward direction to hold it in its position. That's why it is called as normal force. And there is a many example, like I will show you one other example. If there is a bench in the park, there is a bench in the park and you are sitting on it. So basically, if you are sitting here, you are applying the force on the bench, but bench is also applying the force in the upward direction to hold you at the position, and you are pulled downside by the gravitational force. You are sitting here, then it's a normal force. There are many examples in our surrounding, like a mobile phone on a table, like a aquarium on a table. So there are many kinds of examples. And the second non-habitual example of a contact force is tension force. Have you ever observed, if you take a thread, it will be like this, but if you will tie a rock here, then it will be straightened. You are clearly observing here that it is in a straight position. But observe this string, which doesn't have any kind of rock or weight tied on it. So this is quite springy. Okay, this is the tension force. So we will move to our next topic. The next topic is non-contact force. The I will show you on the slide. Wait a minute. So our next topic is non-contact force. The force that's come in to the action without interaction between two objects. See, if you will observe, wait, if you will observe here, this one, wait a minute, I will explain you. Okay, I will explain you. Huh. Observe here that you are standing behind a car. A car is here, and you are standing behind it, and there is a car, and you are trying to push it forward. The car will not move forward as it is very heavy. If your friends joins you to push the car will be easily go forward. But this is an example of contact force because there is a contact between your hand and the car. So in non-contact force there is a opposite. The force that comes into action without interaction between objects is known as non-contact force. Like an example I will give you. If you will try, there is a magnet with north pole and south pole, and there is one another magnet with south pole and north pole. You know, south, these poles do not attract because they are not opposite, they are same poles. So if you will push this magnet forward by the repulsion of this magnet will move forward. So this is an example of non-contact force. So it is clearly said that the force that comes into action without interaction between two objects is known as non-contact force. Here, any kind of interaction between these two magnets are not done. You are clearly seeing that they both have many space between it. So here there is another definition, or the force applied by one object over another without physical contact in between them is also called as non-contact force. And the same definition is here but in other words and short definition is there. You can write both of it or you can write one of it. There are some examples given here of non-contact force like magnetic force, gravitational force and electrostatic force. We will move to our next topic. Wait a minute. Yes, so now wait. Our next topic is momentum. So it's not quite hard topic, but you will take time to understand it. Here clearly it is mentioned that momentum definition is mentioned here. Wait. Momentum definition is mentioned here that the product of mass and velocity of a body is called as momentum. Like the mass and the velocity, if you will multiply the mass by the velocity, you will get the momentum. So here is the formula for this thing. You have to note it. It's IMP. It's important point. So it's clear that momentum is equals to mass multiplied by velocity, or you can write it in the form of a mathematical way like P is equals to m multiplied by v. Here P denotes the momentum and m denotes the mass and v below denotes the velocity. Here are some main points given here. It is a vector quantity, means momentum is a vector quantity. The SI unit of kg यानी कि kilogram meter per second or Newton second. Okay, though it is called as SI unit, kilogram meter per second or Newton second. Change in momentum. Here you will find the change in momentum. Why there is this much difference between it? You will think that this one is also for the momentum and this one is also for the change in momentum, but you didn't observe that this is only for momentum and this is for the change in momentum. There are two types of momentum: final momentum and initial momentum. Both have same formula to find. For finding the initial momentum you have to apply this same formula. This momentum is equals to mass multiplied by velocity, and for finding the initial momentum you have to use this same formula again. So for using this, you have to find the momentum first. If any in any question it is said to be find the change in momentum, just use this formula. If P2 is not given, then find P2. To find P2, we know that it's initial momentum. No, the P2 is called as final momentum. So we know that to find the final momentum and initial momentum, there are same formula. That is P is equals to M multiplied by V. Okay, you have to find by this the momentum, and you have to apply all the momentum that you find, and you will get the answer that delta P is equals to P2 minus P1, means final momentum minus initial momentum. Got it? If you didn't got it, just tell me in the comments. We will clear this doubt in the next lecture. In the next lecture, we are going to solve many kind of questions, and we are going to take the doubt session. You have to comment your doubts in the comment section, and I will see it, note it down, and clear your all doubts in next lecture. So we will move towards our next topic, that is the force is equals to mass multiplied by acceleration. To find the force acting on a body, not, I didn't tell you that it is total force, it's only force you have to find. For this is given. Okay, for this it is given, you have to find this. For this it is given here, mass multiplied by acceleration. You have in the question you have will be having the mass quantity of the mass and the quantity of the acceleration, that the changes in the velocity. Here you will be able to see 1 Newton is equals to 1 kg multiplied by 1 meter per second square. Means 1 Newton is equals to 1 kg multiplied by 1 meter per second square. You can note it down. 1 Newton is equals to, you will get many questions on this. That 1 Newton is equals to 1 kg multiplied by 1 meter per second square. In 8th class foundation course, the questions is given on this, but for the 8th class it is not sufficient to study, so you have to study it in 9th class. So for this up to the mark, you have to note it. We will move to our next topic, that is kilogram force. Here it is clearly mentioned that the 1 kilogram force is equals to 1 kg force, means the force which required to lift 1 kg body from the surface is called 1 kg force. Means if you have to lift 1 kg of bucket of the powder, you have to apply the 1 kg force. If you know, it's the simple logic, 1 kg force is equals to 9.8 Newton, and you have to find the 2 kg force, so just multiply the 9.8 Newton into 2. So the answer will be 19.6, means 19.6 Newton. Here 10 kg force you have to find as the same as the given upside. 10 multiplied by 9.8 Newton, which is equals to 98 Newton. You can find the 100 of it. So it's quite easy topic, so you can understand it very simply. Wait, okay, you will find it very easy. So you have to note this, it's IMP. So please note it or take it the screenshot by pausing the video. We will move our next topic. There are some general topics given here which is used very well. Here it is given weight is equals to mass multiplied by acceleration due to gravity. There is a difference between mass and weight. weight. In weight, the acceleration due to gravity is involved, but in mass, the acceleration due to gravity is not involved. In this, weight is equals to mass multiplied by acceleration due to gravity. You can write here W is equals to M multiplied by G, where W denotes weight, M denotes mass, and G denotes gravity. Here, the mass, to find the mass, there is a formula given here. You can change this formula to find mass. So here mass is equals to weight uh, by acceleration due to gravity. There the question will be given inside the question, acceleration due to gravity. You did not have to find it. And here the initial momentum P1 is equals to m multiplied by v. For the same final momentum, the same formula is there. I told you in the first or second topic about this that there is the same formula. So you have to not note it down because you have noted it in the first or second slide. So for this class we are been done this type of practice about the same topics. If you will get any kind of doubt, just put it in the comment section. I will see it and I will clear your doubt. And for this video, please don't forget to like, subscribe, and share with your relatives. Bye bye. We will meet in the next class.